Okay, so this video is going to look at separable differential equations. And so what I said in my introduction to this is I said basically you can write a separable differential equation as some function of x times some function of y. And so then what you can do is you can get that as 1 over g of y dy equals f of x dx, and then you've got all y's on this side and you've got all x's on this side, and you just integrate and you just go with it. Okay, so let's do some examples here so you can see what's going on. First example I'm going to do, this one's going to look kind of a little bit complicated, but it's all set. Okay, so, well, let's just start breaking it into f of x and g of y. So what I actually want to do is I'm going to take this as 1 over x squared, and then I'm going to do times y squared plus 1 over 2y. And so then if I sort of fuss this around, I'm going to have 2y y squared plus 1 dy equals 1 over x squared dx. Now I'm going to integrate both of those sides. Now this one, what I'm going to do is I'm going to say u is equal to y squared plus 1, du is equal to 2y dy, and so there's my 2y dy. So I'm going a little bit quicker here now that we're getting towards the end of calculus. So that's all going to become du, that's going to become u. So I'm going to have the integral of 1 du over u equals the integral of x to negative 2 dx. So I'm going to have ln u equals negative x to negative 1 plus c. So I'm going to have ln of y squared plus 1 equals negative 1 over x plus c. Okay. Or, so that's one place that I'm going to go with it. But then we could also take it a little step further if you really want a y equals, and in my next video we're going to sort of talk about the pros and cons of making it y equals. I could also say that that's y squared plus 1 equals e to the negative 1 over x plus c. And I could say that I'm going to write that again. Y squared plus 1 is equal to e to the negative 1 over x times e to the c. Well, if c is an unknown constant, then e to the c is an unknown constant. So I can say y squared plus 1 is equal to c e to the negative 1 over x. And I can say y squared equals c e to the negative 1 over x minus 1, or y equals square root plus or minus square root of c e to the negative 1 over x minus 1. So that's another way to write that. Okay, so let's see if we can cram. So another thing you might be asking is, that's sort of one way of writing it, but I attached this 2 to the y. Now, how did I know to attach that 2 to the y? What would happen if I attach that 2 to the x squared? So let's go over and sort of do it that way. So if I did, that would make this over here, it would make it become y over y squared plus 1 dy. And then I would have equals the integral of 1/2 x to the negative 2 dx. And now I would say I'd do the same thing, but now I'd say that dy is equal to du over 2y. So I would, and u is equal to y squared plus 1, sort of just copying this stuff over again. So I'm going a little bit quickly on it. And so what I would have is I would have 1 over u, or I'd have y over u, du over 2y. That y would cancel that y. And so I would have 1/2 integral of 1 over u du is equal to 1/2 of the integral of x to the negative 2 dx. And so now I've got matching 1/2s on both sides. So I can just cross out the matching 1/2s on both sides, and then I'm back to this integral over here. So that 2, it's not absolutely super critical that I attach it to the y as opposed to the x squared. It just works out a little bit better because then this is the derivative of that, and it all just works out. It's a cooked problem anyways. Okay, so there's there's one separable differential equation, but we got 3 more in the loop, and then we'll sort of come back and do a little bit more on that in the next video. So let's do this one. Let's just work through some problems here. Okay, dy dx is equal to e to the y sine x. Okay, well that means that I've got divide this side by e to the y, multiply by dx, multiply that by dx, divide by e to the y, and I've got 1 over e to the y dy is equal to sine x dx. Integrate both sides. That's e to the negative y Okay, so now, once again, that's a stealth chain rule problem. Remember, the integral of e to the y is e to the y, but the integral of e to the negative y is going to be negative e to the negative y equals negative cosine x plus c. So then I can say e to the negative y is equal to cosine x plus c. Why didn't I change that from positive to negative? Because it's an unknown constant. So now if that was positive, now that's negative, but it's still unknown. So that's one way of expressing it. Then I could also say that negative y is equal to the ln of cosine x plus c. Now here the c gets locked in the parentheses, and I could say y is equal to ln of cosine x plus c. And that's about, so that's another way of writing that one. Okay, then next one I want to do, dy dx is equal to 5x plus 3y. And so then what I do is I subtract 3y from both sides. And so I get minus dy, I get minus 3y dy is equal to 5x dx. And so then I integrate that. And so I get negative 3/2 y squared is equal to 5/2 x squared plus c. Now, hopefully, a bunch of you have said, wait a second, what's he doing? He's made some math errors. And I have made math errors, and I was hoping that you would pick up on this, so hopefully you picked up that I made some math errors. Right? That's not right. I can't just do that. If I get if I do it right, I get dy dx minus 3y is equal to 5x. Then if I multiply that by dx, I get dy minus 3y dx equals 5x dx. And that's not right, because there I've got a y and I've got a dx. So I cannot separate this, because if we go back, it's got to be a function of x times a function of y. Function of x times a function of y. This is a function of x plus a function of y. So that whole thing, that's not separable. If you can't get it down into a function of x times a function of y, it is not separable. Okay, so then let's look at this one. And you go, ha, same thing. Here I've got a 5x plus 3y. I'm not going to be able to separate that out. Ha ha. Here we got to pull this up here. That one right there. Let's zoom in and focus in on it. I'll let you think about that one for a second. Well, is it separable or is it not separable? Now I'm thinking that it's not separable. Okay, so I'm basically convinced that it's not going to be separable, but let's see. So we've got sine let's pull it in. Sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. Okay, so then I've got, sort of jumping ahead, I've got sine 5x cosine 3y plus cosine 5x sine 3y. And I just sort of look at this and I go, oh, there's no way I'm going to be able to get all the x's and y's, all the y's on one side and all the x's on the other side. It's just not going to work, because if I divide this by cosine 3y, then I still have a y attached to that, and it's not going to work. Okay, so that one's not going to work. So then last one that I want to do, so that one's not going to work either, right? Well, no. Because of our exponent rules, I can rewrite this like that. Bam. So then I can write e to the negative 3y dy is equal to e to the 5x dx. Integrate both of those, and I get negative 1/3 e to the negative 3y equals 1/5 e to the 5x plus c. And so then I can do e to the negative 3y, I can leave it like that. I can go e to the negative 3y equals negative 3/5 e to the 5x plus c. Or I can say negative 3y is equal to the ln of negative 3/5 e to the 5x plus c. And I could say that y is equal to negative 1/3 ln negative 3/5 e to the 5x plus c. Okay, because I didn't want to go on to another sheet of paper. Okay, So those are my examples for separable. So there you have some equations that are separable differential equations, and I'm going to look at domain and range in the next video.